All right, we're going to talk about reasoning in algebra today. So the first thing is we got to talk about properties of equality. Okay, so let A, B, and C be any real numbers. Addition property. If A equals B, then A plus C equals B plus C. Subtraction. If A equals B, then A minus C equals B minus C. Multiplication. If A equals B, then A times C equals B times C. And then division. If A equals B and C does not equal 0, then A over C equals B over C. Reflexive property, A equals A. This is really important in geometry because there are going to be times where we have to state that an item is equal to itself or congruent to itself. Symmetric property, if A equals B, then B equals A. So we can flip that around. It doesn't matter order. So the left side can go to the right side can go to the left. Transitive property, if A equals B and B equals C, then A equals C, right? So I can kind of take out that middleman and we still have equality. Substitution, really, really important. If A equals B, then B can replace A in any expression and vice versa. Distributive property, you guys are pretty familiar with this. Use multiplication to distribute A to each term of the sum or difference within a parentheses. So here we have the sum. A times the quantity B plus C equals AB plus AC. Difference is A times the quantity B minus C is AB minus AC. So here's our example here. So 3 times the quantity 2x plus 5. I'm going to take this 3, multiply it by each of them. 3 times 2x is 6x, plus 3 times 5 is 15. Okay, so here we have a given. So we have angle 1 is equal to 2x plus 30, and angle 2 is equal to x. We're going to find x. Now, we can't just find x just based on this information. We need a little bit more. So, angle 1 and angle 2 are a linear pair. That's important because remember what a linear pair is. So a linear pair means that the addition of them equals 180. So angle 1 plus angle 2 equals 180. All right. Now what I'm going to do is I'm going to substitute in what angle 1 and angle 2 are. So angle 1 is 2x plus 30. Angle 2 is x. That equals 180. I'm going to do a little bit of simplifying on my left side. So I'm going to take 2x and x and add them together. So 3x plus 30 equals 180. That's just addition. I'm going to subtract off my 30 from both sides to get 3x equals 150. And then the reason was subtraction. And then I'm going to divide. So 3x divided by 3 is x. 150 divided by 3 is 50. That's division. I found what I'm looking for is x. If I wanted to find these angles, all I would have to do is plug in 50. Okay, properties of congruence. Now, the nice thing about congruence and equality is they go hand in hand. Reflexive property. If segment AB is congruent to segment BC, segment AB is congruent to segment AB. Angle A is congruent to angle A. That's reflexive. Symmetric property. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Holds true for angles. If angle A is congruent to angle B, then angle B is congruent to angle A. Transitive property holds true for both segments and angles. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, and segment AB is congruent to segment EF. We're going to name that property now. So I start with 2x plus 9 equals 19. And then on my next one, I have 2x equals 10. Well, what did I do? Well, I subtracted the 9, so that's the subtraction property of equality. Here I have angle A is congruent to angle B, and angle B is congruent to angle C. And then I have angle A is congruent to angle C. Well, what happened here? Well, I kind of took out my middleman, so that's the transitive property of congruence. Two-column proof. So two-column proofs are very important in geometry, and we're going to be talking about proofs a lot. So different types of proofs. A proof is a convincing argument that uses deductive reasoning. A proof logically shows why a conjecture is true. Okay, so we're going to be looking at one of these. Two-column proof lists each statement on the left, and the justification or the reason for each statement is on the right. So we're going to look at a two-column proof here. Okay, so we're given that measure of angle 1 is congruent to measure of angle 3. So we're given that these two angles are congruent. Okay, so when I'm starting out in a two-column proof, the first thing I'm going to write down is my given. Now, you might not always write down all of the given, but you're probably going to start with some piece of it. Okay, so we only have one piece. There probably should be another piece in here that says like AEC is equal to angle 1 plus angle 2. BED is equal to measure of angle 2 plus measure of angle 3. Probably should have had that up there. That's okay. We're going to kind of extend from it, from our diagram. So now I have my proof is what I'm trying to prove. I'm trying to prove this angle is congruent to this angle, right? AEC is equal to measure of BED. So I'm trying to show that those two are equal. Well, what can I do to both sides to maintain equality? Well, what I could do is I could add angle 2. If I add angle 2 to both sides, did I change my equality? The answer is no, I didn't change my equality. And right here, I just have addition. Right? Now what I'm going to do is I'm going to state measure angle 1 plus measure angle 2 equals the measure of angle, well, here's 1 and 2, AEC. AEC. And really, this probably should have been up here in the given, but we're going to say from the diagram. Okay? And then we're going to say measure angle 3 plus measure angle 2 is equal to, well, 2 and 3 is equal to BED. So the measure of angle BED, that is also from the diagram. Now, here I have measure of angle 1, measure of angle 2. Well, what is that equal to? Well, that's equal to AEC. So measure angle AEC is equal to, well, I have measure angle 3 plus measure of angle 2. Well, what's that equal to? It's equal to measure of BED. Well, what did you do? All you did was substitute. So this is substitution, because you're just substituting what those are equal to. Right? So that's a quick kind of example of a two-column proof. You're going to start with your given. You're going to proceed from there. You guys have done this in algebra before. So if you had 2x plus 1 equals 5, and you said, well, my first step is I'm going to move the 1 over. I'm going to subtract it over, and then you had to write subtraction. That's all a two-column proof is. All right? Joke time. What did the mama cow say to the baby cow? It's past your bedtime. What's a pig's favorite fairy tale? Sleeping Beauty. So that's kind of an introduction to two-column proofs and getting you starting to look at some of those properties in equality and congruency.